full wave bridge rectifier. Hello everyone, my name is Rafael, I'm an electrical engineer, and in this video I'd like to discuss with you the full wave bridge rectifier. And to do so, I chose this problem here. I am going to read the exercise and show you the solution. Let's do it. Full wave bridge rectifier. A full wave bridge rectifier circuit with a 1 kilo ohms load operates from a 120 RMS volts 60 Hz household supply through a 10-to-1 step-down transformer having a single secondary winding. It uses 4 diodes, each of which can be modeled to have a 0.7 volts drop for any current. This is the voltage drop of the diode. Letter A. What is the peak value of the rectified voltage across the load? Letter B. For what fraction of a cycle does each diode conduct? Letter C. What is the average voltage across the load? And the letter D. What is the average current through the load? Okay, my friend, this is what we want to calculate. Let's begin. Let's begin with the letter A. Letter A wants us to calculate the peak value of the rectified voltage across the load. Okay, so here I've drawn it. This is the input voltage here. Okay, 12 RMS. If you want to find the peak, you have to multiply by the square root of 2. Okay, and this is going to be the voltage across the load. We're going to calculate this. The peak voltage across the load is VL. The peak value VL is going to be equal to VS peak minus 2 times VD. Why 2 times VD, you may ask me? Because there is a reverse voltage here, okay? VD here, and since there will always be 2 diodes in the path of current, okay? For example, the current is going to go through here, this diode here, pass through the load and return through this diode here and go there. So there will always be 2 diodes along the path of current. Then this reverse voltage drop here will be 2 times. Okay? Then we find that it is going to be equal to 12 times the square root of 2 minus 2 times 0.7 volts. And if we multiply this and subtract from this, we find 15.57 volts. Here I put only 15 volts, it's approximate. The actual value is 15.57 volts. Okay, this is letter A. Now we go to letter B. Letter B wants us to calculate the fraction of a cycle that the diode conducts. Okay, to calculate letter B, we need to firstly discover this angle here. what does this angle mean? See here in the graph that Vs begins at 0, okay? The sinusoid begins at 0 here. But the rectified voltage that goes to the load is not going to begin at 0. It's going to begin at theta because of this reverse voltage here, okay? And since there are two diodes along the path of current, then it matches the voltage of 1.4 volts. So we are going to calculate this. Okay, theta, first of all, theta is going to be the inverse sine 1.4 volts divided by 12 square root of 2 volts, okay? With this expression here, we can calculate the value of theta, which is in radians. Theta in radians is equal to 0.0826 radians, or if I prefer, theta is equal to 4.73 degrees, okay? So the diodes will not conduct between 0 degrees and 4.73 degrees. The diode is going to start conducting only after 4.73 degrees. Okay, we are going to use the radians, but just to tell you, it's possible to use the degrees. And now for letter B, letter B wants us to calculate the fraction of the cycle the diode conducts. The fraction of the cycle will be pi, which is corresponding to 90 degrees, minus 2 times theta, okay, because here there is a small gap here that the diode doesn't conduct, and here as well, okay? There is this part here as well. Divided by 2 pi, okay? And it is going to be equal to pi minus 0.1652 divided by 2 pi, and this is equal to 0.474 radians, or if you prefer, if we multiply this by 100%, it is going to be 7. No, this is not in radians, okay? This is not in radians. Sorry, it was a mistake that I made. This is not the angle. This is the fraction of the cycle it conducts, okay? So it's going to be 47.4%. All right? This is not the angle. This is the fraction of the cycle the diode will conduct. Each diode here, each one of these diodes will conduct for 47.4% of the cycle. Alright? So this is the answer of letter B. Now we are going to calculate what letter C wants us to calculate. And letter C wants us to calculate the average voltage. How can we calculate the average voltage? The average voltage for letter C volt for letter C is going to be V0 average will be equal to 2 times divided by 2 pi from theta to pi minus theta, okay? Because in pi is 180 degrees, okay? Pi is 180 degrees. And from here to here, okay, from 0 to the other point here is 180 degrees. And we have 2 small parts here that it doesn't conduct. Okay, 12 times the square root of 2 sine phi minus 2 Vd d phi. And there will be 2 of these in 360 degrees. Here and here. That's why we have to multiply by 2. There will be 2 of these peaks here in 360 degrees. And then, conducting this calculation, we find that it is equal to 1 over pi from the integral from theta to pi minus theta of 12 times the square root of 2 sine phi d phi, sine phi d phi, okay, we have brackets here, minus, again, the integral from theta to pi minus theta, 1.4 d phi, and then we close the brackets. Now we need only to solve this integral. I'm going to erase here to show you the next step. And then we find that it is going to be equal to 1 over pi minus 12 times the square root of 2 times the cosine. Okay, when we integrate the sine, it becomes negative cosine, minus 1.4 phi theta pi minus theta. Okay, we begin here again. I'm going to show you the limits of integration. We begin at pi and we integrate until here. This point is pi minus theta. Okay, we integrate from here to here. We integrate only from here to here. Okay, and in the beginning we multiplied by 2 because in 360 degrees there are 2 peaks, this peak and this peak. That's why we integrate from pi to pi minus We integrate from theta to pi minus theta, from theta to pi minus theta, and then we multiply by 2 because there are 2 peaks in 360 degrees. Did you get it? Okay. And lastly, we find that it is going to be 1 over pi 12 square root of 2 times the cosine of phi from theta to pi minus theta minus 1.4 phi from theta pi minus theta, and this is if we use that pi is equal to 180 degrees and that theta is equal to 4.73 degrees, we find the value of 9.44 volts. Okay, this is the result. This is what we wanted to find for letter C, the average value of the output voltage. Okay, letter C wanted us to calculate this, the average value of the output voltage, the voltage across the load. Okay? Yes, I'm calling this V0, but remember that V0 is equal to VL here, okay? VL means the voltage across the load, and V0 the output voltage, you choose, okay? There is no need to misinterpret this. Okay, this is letter C, and the last is letter D. Letter D, let's go, letter D. What does letter D want? The average current through the load. The average current through the load is easy once you calculate the average output voltage. The current delivered to the load average is going to be the value that we just calculated for the output voltage divided by the load resistor, and then we just plug in the values, okay, and the voltage of 9.44 volts divided by 1 kilo ohms, and we find a value of 9.44 milliamperes. All right, my friends. This is the last result, the result of letter D. And just to finish, just a curiosity, normally we don't want peaks like this, okay? We don't want peaks like this. We want the output voltage to be linear like this. Alright, so what can we do to make the output voltage linear like this? We can simply use a capacitor together with this resistor here. Okay, the resistor is here, and then the rectifier is going to be here, okay? Rectifier. The rectifier is going to be here, and then the load resistor here, and then we put a capacitor in parallel with the resistor to make the signal linear like that. Okay, we can use a capacitor of 100 microfarads. Okay? All right? Okay? We can use voltage regulators as well. Okay, there are many things that we can do to stabilize the signal here and make it linear instead of pulsating such as this. Okay, my friends, this was the video that I wanted to make. I hope you guys enjoyed and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye.